All right, this is the first of a lot of videos you're going to watch this year. Here, there's going to be three things that I really want to cover. First of all is the phrase "in terms of." And we're going to take a look at what it means to write a function in terms of a certain variable. We're also going to take a look at the special triangles, the 45, 45, 90, and the 30, 60, 90 triangle. And I want to talk about our graphing calculator and how that relates to AP Calculus. Let's start by finding P in terms of X. Now, what this phrase "in terms of" means is I'm going to find this function P, and I'm going to write it so that we'll have P equals, and the expression on the other side only has X's in it. Right now, we have that P is equal to X times Y. So I found P. P is equal to X times Y. But it's written in terms of X and Y. If we think of that as functional notation, that's really P of X and Y is equal to XY. And what we want is to change this into a P of X statement and find out what that's going to be. In order to do that, we go back to our initial equation here. This 3x plus y is equal to 10. I'm going to want to solve that for y. Notice y, not x. To do that, of course, we just subtract 3x from both sides, and we get y is equal to 10 minus 3x. I wanted to solve the equation for y so that now I could take and substitute that value in for y right here. Then we'll have P of X is equal to X times Y. But Y is not written in terms of Y now. Now it's written in terms of X. So I use that 10 minus 3X. So P of X, when we distribute the X, would be 10X minus 3X squared. Let's try another one. Find A in terms of Y. Right now, A is written in terms of X and Y. We're going to want it to be A written in terms of just y. So this side of the equation will only have y's in it, which means I need to substitute that x out. So we go back to that first equation and we solve it for x, which means I'm going to add 11 to both sides. And this turns into x is equal to y plus 15. So now we can rewrite A in terms of y by taking out this x and plugging in this expression for it. So we'll have y plus 15 plus y squared. Of course, we should make things nice and neat. So A of y would be y squared plus y plus 15. Next, let's take a look at some special triangles. We have two types of special triangles. The first one being the 45, 45, 90 triangle. And the reason 45, 45, 90 is so special is because of the square. When we start with a square and we cut it along the diagonal, what we're left with is a right triangle. And of course, the angle measures for this right triangle are going to be 45 degrees, 45 degrees, and 90 degrees. Now, what I expect from you is to understand the ratio of the three side lengths. So if we started with one side having a length of 1, well, since we have these two congruent angles, that means their opposite sides are congruent as well. So if the base has a length of 1, so does that height. And of course, we can just calculate the length of the hypotenuse using the Pythagorean theorem. 1 squared plus 1 squared equals c squared. 1 squared plus 1 squared is 2, which means when we take the square root, this hypotenuse is going to have a length of square root 2. So you need to remember that 1, 1, square root 2 ratio. So then if we have another 45, 45, 90 triangle, these two sides are going to be congruent, and we know now that the base is 3. Well, if the base is 3, the height is 3, and the hypotenuse is going to be square root 2 times as big as those sides. So 3 square root 2. And be able to go backwards so that if I have a hypotenuse that's 1 and I want to go backwards to the legs of the right triangle, Well, I know that when I went from the base to the hypotenuse, I multiplied by square root of 2. So now if I'm working backwards from the hypotenuse back to the base, I now have to take that 1 and divide it by square root of 2. And both sides will be the same. So this will also be 1 over the square root of 2. You should be used to rationalizing the denominator. So by that, we mean multiplying numerator and denominator by that square root 2. And square root 2 down here. So we could rewrite 1 over the square root of 2 as root 2 over 2. And if we try one more, maybe where the hypotenuse is 8. So of course, to get to our two bases, we're going to have to take 8 and divide it by the square root of 2. Rationalizing the denominator would mean multiplying numerator and denominator by square root of 2. And we'll end up with 8 root 2 over 2, which of course we can simplify to 4 root 2. So the base here is going to be 4 root 2, and the height of this triangle is going to be 4 root 2 as well. The second kind of special triangle is the 30, 60, 90 triangle. And that one's special because it evolves out of the equilateral triangle. Because in an equilateral triangle, all of the angles are going to be 60 degrees. Here, here, and here. But to get a 30, 60, 90 triangle, we're going to take this equilateral triangle and cut it in half vertically, like this. And we're left with this kind of triangle. Let me make it a little bit bigger here. And what we see is our angle measure of 60 degrees is still 60 degrees right here. Because we drop that altitude from the peak of this triangle, we end up with our 90 degrees down at the bottom. And of course, the top angle got cut in half, so that's where our 30 degrees is. 30, 60, 90. Again, we want to be able to identify the ratio of the side lengths. This time, I'm going to think of the hypotenuse first as having a length of 2. Because remember, this came from an equilateral triangle, and so when it came to the base, that equilateral triangle had a base that was 2, but we cut it in half, so now its base is 1. Of course, we can use Pythagorean theorem again to help us out. This time, I have 1 squared plus b squared is equal to 2 squared. So I subtract 1 from both sides. B squared is going to be 4 minus 1, which is 3, and then we square root both sides. So that's how we get our third side to be square root of 3. So we need to remember this ratio of 1, 2, and square root of 3. It's a square root of 3. Don't fool yourself into thinking that square root of 3 is 3 and that it's the biggest number that's there, because it's not. Square root of 3 is smaller than 2. So if I have the shorter base here, having a length of 6, we can work our way around the triangle by doubling it to get the hypotenuse of 12 and multiplying it by square root of 3 to get the height. Now, if we start on some other side, maybe we start with the hypotenuse being 6. Work your way back to the shorter side first, because that shorter side is going to be half as big as the hypotenuse, so it'll have a length of 3. Then, to go from the shorter leg to the longer leg, we just multiply that by square root of 3. The trickier one happens when it's the longer leg that has that length of 6. We still want to work back to the smaller side first. Remember that when we go from the shorter leg to the longer leg, we multiply by square root of 3. Now we're working backwards, so we're going to want to take that 6 and divide it by square root of 3. Of course, rationalize the denominator, so multiply the numerator by square root of 3 and the denominator by square root of 3, and we're left with 3. Then simplify that fraction as 2 square root of 3, and that's the length of this shorter side. Now, to go from the shorter side to the hypotenuse, we double it. So instead of 2 root 3s, now we'll have 4 root 3s. The third thing I want to show you is how to use a graphing calculator to do a few things. I can't put it in this video because of the program that I'm using to make the video. So I'm going to use a different program, show you how to use TI-84, and then I'll post that as a secondary video